Okay, now let's start with question number 6. This question is about the energy changes that take place during the chemical reaction. Methane reacts with chlorine to make chloromethane. This reaction is exothermic. Okay, it means the delta H is negative, right? Drawn the provided in figure 6.1. The reaction pathway diagrams for this reaction include labels for excesses, reactants, products, enthalpy change, and activation. You have to cover all these 5 points and seats of 5 marks. So it's uh, it's a scoring one. These 5 marks are really very scoring. So what happens? What is the exothermic reaction? If you recall, it is the reaction in which energy is released when the reactants react, right? So it means that if the energy is released, yeah. So what happens to the what will be the energy of the product? The energy of the product is going to be lesser than the energy of the reactants. Okay. Just give me a minute, please. Okay. So here we are going to have our reactants. And here we are going to have our products. Okay. So we are done with the reactants, we are done with the products. Now, okay, excesses. So remember, on y-axis, it's a energy, or you can write enthalpy. And on x-axis, it's a reaction pathway. So we are done with the excesses as well. Now, you have to make a arc like this and meet two lines. Now, yeah, you can write the progress of a reaction as well. No, it's not reaction time. Okay. Now, from the reactants till the highest point, we have activation energy. And remember, activation energy is always starts from the reactant to the highest point. And do remember this thing, you have to put the arrow over here only. If you put the arrow over here, then you will be marked wrong. Or instead, if you label it like this and put a EA, then it's still you are not going to get any marks. So you have to put the arrow over here, which shows that the energy is being absorbed, the energy is increasing. Then starting from the reactants and reaching to the point of the and labeling this one is the enthalpy change, delta H. Is this clear to all of you? So see, we are done with the enthalpy change and we are done with the activation energy. So you guys secured 5 marks. Okay. Now, question number 6. Hydrogen iodide decomposes to make hydrogen and iodine. Calculate the enthalpy change of this reaction. Use the bond energies in table 6.1. So if you recall the formula is that the enthalpy change is equals to bond energy of the bonds broken minus bond energy of the bonds formed. So if you see how many moles, there are 2 moles of hydrogen iodide. So it means that the bond energy of hydrogen iodide is going to be times 2, and these are the reactants, so these are the bonds which are broken. There is a 1 mole of hydrogen bond, and there is a 1 mole of iodine bond. So these are the bonds which are found because these are the bonds which are at the product side. And there they have their 1 mole, so we have to keep it times 1 only. Yeah, it's better to draw the diagram with the pencil. So bond broken would be 2 times 298 minus 436 plus 151, because there is of a iodine bond and 1 mole of a hydrogen bond, so we do not need to multiply them. Can anyone calculate it and tell me the answer? It's 6, it's 8, and it's 5 minus 7, 8, and 5. No, 1 minute. 2 8 is 16, 2 9 is 18, 19. So it's going to be 9 and 1, 2 2 is 4, 596 and 2 8, 587. Yeah, it's a positive 9, Huzaifar. Check your working. So answer is getting in a positive. So you must write the sign over here and then the unit, it's kilojoule per mole. Is this clear to all of you? Now, okay, so positive 9. Question number 7. Methanol, propane 1-ol, and propane 2-ol are alcohols. The displayed formula of methanol, propane 1-ol are shown. State the general formula of the homologous series of alcohol. So if you recall the general formula of the homologous series of alcohol, there are two CnH2n plus 1 OH or CnH2n, sorry, plus 2 O. So you can write any one, but you have to remember this. Now, propane 1-ol and propane 2-ol have the same molecular formula but different structural formula. State the name given to the compounds that have a same molecular formula but different structural formulas. Yes, what we call them? Very good, Rahim. So these compounds are called isomers. Now, draw the structural formula of propane 2-ol. So see, they have clearly mentioned that you have to draw the structural formula, right? So if you see it's a propane 1-ol, let me make the displayed formula over here. So prop means 3 carbons, so I put a 3 carbons, and it's a propane 2-ol, so OH is on the second carbon, right? So first carbon is going to have a 3 hydrogen, second carbon is going to have a 1 hydrogen, and the third carbon also going to have a 3 hydrogen. So the structural formula would be CH3, CH, OH, CH3. Or you can, instead of this, you can make it like this: CH3, CH, CH3, and OH over here. So see, it is also considered as a structural formula, but the best or the most appropriate way of making the structural formula is the one which I draw on the top. Okay, now next part. State why propane 1-ol is a saturated compound. Yes, I think it's very easy. Who can tell me the answer? Yes, who is going to tell me the answer? It is because, yes, Mustafa, it contains, very good, Shayan, very good, Hania. But Hania, your answer is relatively incomplete. So it is because it contains only single bonds between carbon atoms that you have to, if you just don't write single bonds. Yes, but it's Zaid, it's more appropriate to mention the single bond, okay? It is because it contains only single bonds between carbon atoms. State why propane 1-ol is not a hydrocarbon. Yes, It has oxygen as well. Very good, Shaya. It contains oxygen as well, along with hydrogen and carbon. Okay. Now, 7E. Propane 1-ol reacts in the same way as ethanol. Draw the displayed formula of the product of the reaction of propane 1-ol when with acidified potassium, aqueous potassium magnate 7. So, can anyone recall which reaction is it? No, it has a carbon hydrogen bond in ethanol in propane 1-ol, Rahim. See, it's a propane 1-ol. So there is a OH, but beside this, the rest of the bonds are carbon hydrogen bonds. But why we can't call it hydrocarbon? Because it's not just carbon and hydrogen, it contains an oxygen in it as well. Is this understandable? Okay. Yes. When we use potassium magnate, which reaction is it? If you guys recall, it's an oxidation. And in oxidation, when alcohol is oxidized, it converts into which compound? It's a carboxylic acid, right? So if it's a propane 1-ol, so how many carbons it has? 3 carbons containing alcohol. So it means we have to make the displayed formula of a 3 carbon containing propanoic acid, means carboxylic acid. So on the terminal carbon, I make the functional group carboxylic acid. This carbon is going to have a 2 hydrogens and this carbon is going to have a 3 hydrogens. Is this understandable to all of you? Okay. Now, draw the displayed formula of the product of the reaction of propane 1-ol with ethanoic acid in the presence of catalyst. Which reaction is it? Can anyone recall this reaction? Yes, very good, Josefa. It's a esterification. So there is a propane 1-ol and you have to make the displayed formula. So 1, 2, 3, and here we are going to have a OH. Okay, do one thing whenever examiner asks you to for this kind of a question, make any one compound as a flipped compound. Means that if I'm making propane 1-ol like this, I'm keeping the ethanoic acid over here and make this carbon a carboxylic acid and keep this carbon a simple alkyl. Okay, so what happens if you guys recall in esterification? OH from carboxylic acid is removed and hydrogen from alcohol is removed to form water. Now, if you see this structure, this oxygen needs one bonds to be made, and this carbon has a 3 bonds. So this carbon also needs one more bonds to be made. So we join these two structures like this, and we will get a ester. Is this clear? If any one of you has confusion, please ask. Yeah, it's a condensation reaction, Hania. Very good. So that's how you keep the functional group of one, either alcohol or carboxylic acid on the right, and the functional group of either the other one on the left. Then remove the hydrogen from the alcohol and OH from the carboxylic acid, and from those 2 points join the 2 molecules to make the ester. Then you will always going to form the ester, correct? Methanol is a covalent substance. Okay. Draw a dot and cross diagram to show the bonding in the molecule of methanol. Include only the outer shell's electrons of each atom. Okay, you have to draw dot and cross, right? So if you recall a methanol, isn't it like this? That a carbon has a OH and that carbon has a 3 hydrogens bonded to it. Where Shayan? No, in this case, a water is found, but they don't ask you to the all of the product. They just ask you to the draw the display formula of the product. So displayed formula is for organic compounds only. So that's why we have drawn only organic compound. Okay. So you got the displayed formula. So if you make the displayed formula, then it is very easy to form the, dot and cross. So what you are going to do, you are going to put a one carbon in the middle, one hydrogen, second hydrogen, third hydrogen, oxygen, and fourth hydrogen. So there is all of them have a single bond, right? So it means there is only one pair of electron over here. Now, carbon has a four electrons in its valence shell, and all of the four electrons are involved in the bonding. Hydrogen has only one electron, and see, these all one electron are involved in the bonding. Oxygen has 6 electrons in its valence shell, and out of these 6 electrons, only 2 electrons are involved in the bonding. So 4 are left. So we are going to make the 2 lone pairs on oxygen atom to show those unbonded electrons. Okay, next part. State why a methanol does not conduct electricity. So if someone doesn't conduct, if any compound doesn't conduct electricity, so what does it means? Yes. Very good, Rahim. It does not have free moving electrons. Next. Methanol is used as a solvent. State the meaning of the term solvent. Very good. Ahmed Mujtaba. We can write a solvent is a substance or is a liquid in which solute is dissolved. No, dissolved in water. Water is an example of a solvent, okay? So you have to, they ask you the general term solvent. So solvent can be anything in which if we add something and if that something is dissolved in that liquid, then it's a solvent. Okay. Now question number 8. This equation is about electrolysis. The table shows some information about the electrolysis of 3 different electrolytes using graphite electrodes. With the name of the table 8.1, complete the table 8.1 with the names of the products at each electrode. So you have to write the products. You don't have to write the ions which attracted towards those electrodes. Okay. So if you recall, anode attracts anions towards itself. So anode is a positive one. So negative ion would reaches to the anode and forms an element. And cathode attracts cations towards itself, and cations are positively charged. So which means cathodes are negative ions. Oh, sorry, negative plates. So it attracts the positive ions towards itself, and when the positive ions approaches to cathode, it turns into element. So it's a dilute aqueous potassium chloride. So it means it has a potassium ions, hydrogen ions, chloride ions, and hydroxide ions. So at anode, which ion is going to be reaches? Yes, very good, Khatija, as it's a dilute solution. So hydroxide ion reaches to the anode and it turns into oxygen. Yes, very good, Aisha. Very good, Abdul Hadi. Rahim, you are wrong. So here we are going to get oxygen. And at cathode, which ion turns into element, potassium or hydrogen? Yes, very good, Umar. Very good, Rahim. Very good, Khatija. It's hydrogen, because for cathode, we always identify from the reactivity series, and the rule is that the one which is below is going to reduce at cathode. So potassium is at the top and hydrogen is in the middle. So we are going to get hydrogen over here. Okay. Now we have aqueous copper sulfate. So it means it has a copper 2 positive ions, hydrogen ions, sulfate ions, and hydroxide ions. So what we are going to get at anode? Which ion is going to attract it towards anode, sulfate ion or a hydroxide ion? A hydroxide ion, very good, Rahim. Sulfate ion doesn't attract it towards anode, and hydroxide ion, when oxidizes at anode, it will again going to form oxygen. So in both of the cases, the negative ion is this hydroxide and this hydroxide, and here the positive ion is hydrogen. And here at cathode, what we are going to get? Very good, copper, because copper is below hydrogen. So copper ion is going to reduce at cathode and forming a copper metal. Is this understandable to all of you? No, hydroxide, you can't write it because see, they have asked you to write the products at each electrode. So hydroxide ion reacts at anode, but it is finally going to form oxygen. Okay. Yes, Mustafa, what you want to be repeated? And here it's a molten lead iodide. So lead is Pb with a 2 positive and iodide is a negative ion. Yes, for a copper 2 sulfate one. So see, sulfate never undergoes. Sulfate and nitrate never never reacts at anode. So in that case, there is only hydroxide. Okay. And when hydroxide reacts at anode, oxygen is formed. Now copper and hydrogen. So copper is below hydrogen, right? So for a cations, the one which is below is going to form element at cathode. So that's why copper is going to form copper metal at cathode, because copper is below hydrogen. Is it clear, Mustafa? Okay. Now, so it's very easy. See, we have only one negative ion and only one positive ion. So iodide ions turns into iodine. Very good, Khatija. And lead ions are going to form lead metal. So it's very easy. Yeah, very good, Rahim, Khatija, and Mustafa. Okay. Now, B part. The electrolysis of aqueous copper to sulfate gives different products when copper electrodes are used instead of graphite electrodes. Describe the observations during the electrolysis of copper electrodes. So that's what we have discussed in electrolysis. The first thing, when there is a carbon electrodes are used, the blue the color the solution the color of the blue color of the electrolyte or the solution fades away. But here the electrolyte solution stays blue. That is the one observation. It doesn't fades. Electrolyte solution stays blue when there are copper electrodes, because the one copper electrode which is the size will be reduced at anode and the mass of the negative electrode increases. Yeah, very good. So it's of 2 marks. So we just need to write, 2 points. So we can write that anode. Or yeah, size of anode decreases and size of cathode increases as it is coated with pink solid. So out of these 3, you can just write 2, you will get the marks because it's for 2 marks. Magnesium is manufactured by the electrolysis of molten magnesium chloride. Okay. At anode, chloride ions reacts to make chlorine molecule, construct the ionic half equation for this electrode reaction. So see, they are telling you chloride ions make chlorine molecule. So there is a chloride ion, aqueous, forming chlorine, which is a diatomic. So diatomic, we have to put 2 over here. So as there are 2 chloride ions, we are getting 2 moles of electrons. So for equation, we have to mention as it's a half ionic equation. So remember, in a half equation, and remember, whenever there is a half equation, you must have to show the electrons with the E negative. Okay. Is this clear to all of you? Now, question number 9. Oxide of nitrogen, such as nitrogen monoxide, are atmospheric pollutants. The exhaust gas from a car engine contains 0.002% by volume of nitrogen monoxide. Calculate the number of molecules of nitrogen monoxide in 960 dm cube of exhaust of a gas at room temperature and pressure. Okay. So they are saying that the volume of nitrogen monoxide is just 0.002% of the exhaust gas. I think they didn't mention, so you will get the mark over here. Okay. So 960 is the total volume of the exhaust gas. So it means that 960 dm cube is how much percent? It's the 100% volume. Now we need to know 0.002%, which is the volume of NO, nitrogen monoxide. So just calculate the percentage of nitrogen monoxide, that how much volume is it in if it's 0.02%. So 960 times 960 times 0.002 divided by 100. Can anyone calculate it and tell me the answer? Okay. It's 0.0192 dm cube. And they are asking for the number of molecules. So we know that, see, they are telling you at room temperature and pressure. So at room temperature and pressure, 24 decimeter cube occupies 1 mole. So if there are 0.0192 decimeter cube, then how much moles are there? There would be X mole. Now calculate the value of X. It's 0.0192 times 1 divided by 24. Yes, can anyone tell me, please? It's the volume of NO. Now I'm going to find the moles of NO. Yes, can anyone calculate this value and tell me the answer, please? Okay. It is 8 exponent minus 4 mole of NO. Right? If you now you have to convert it into a molecules, the number of particles. So the number of particles would equals to moles multiplied by Avogadro's number, which is 6.02 exponent 23. So the moles are 8 exponent minus 4 times 6.02 exponent 23. Can anyone multiply it and tell me the answer, please? Yes, please. Okay, it is 4.816 exponent 20. Thank you, Ahmed. 4.816 exponent 20. Okay, now nitrogen and oxygen reacts to make nitrogen monoxide inside a car engine. Construct the equation for this. Okay, here normally what students are going to do a mistake is that they forgot or they do not able to recall that nitrogen and oxygen both are diatomic. So you have to write N2 and you have to write O2, and they are going to form nitrogen monoxide. Its formula is NO, right? So we have to balance the equation. So to balance the equation, I need to just put a 2 over here. The equation is balanced. Now, part C, state one adverse effect of oxides of nitrogen as a pollutant in the air. Yes, very good, Khatija. It causes acid rain. Now, describe how oxides of nitrogen formed in a car engine are removed by the catalytic converter. So they don't ask you to write the equation, they ask you to explain it. Okay, Shayan, you were saying, yeah, breathing difficulty, it is also a problem damaging the lungs. Hania, that is also, yeah, that can also be written. Khatija, more harmful gases. How they convert it into a nitrogen, Umar? More harmful gases converted into a less harmful gases. That is the general thing. Yeah, not nitrogen reacts because it's the oxide of nitrogen, not nitrogen, Aisha. You are talking about the reaction which is taking place inside the car engine. Inside the car engine, the nitrogen oxide is formed, and it, when reaches to a car exhaust, it reacts with it something at a catalytic converter to form nitrogen. Yeah, yeah, but with which substance it reacts? How it reacts? So oxide, if you recall the equation, in equation the nitrogen monoxide is reacting with carbon monoxide. Yes, Hania, very good. So oxides of nitrogen, no, it's a catalyst, Khatija. Oxides of nitrogen reacts with carbon monoxide to form nitrogen. I hope it's clear to all of you. Yes, what you want to be repeated, Josefa? See the air and atmosphere chapter, you will find over there the catalytic converter reaction, or let me show you. See, this is the reaction over here, the catalytic converter one. Okay. Now, E part. The rate of a diffusion of nitrogen dioxide is less than that of a nitrogen monoxide. Okay. Under the same conditions of temperature and pressure. Explain why the rate of diffusion of nitrogen dioxide is less than nitrogen monoxide, and it's of 1 mark. So if you recall, if you calculate its MR, nitrogen is 14 and oxygen is 16. There are two oxygens. So 14 plus 32, it would be 56. And here it's 14 plus 16. So it's 30 only. So we can just write it is because the relative molecular mass of NO2 is 56 and NO is 30. So the relative molecular mass of NO2 is greater than NO. Is this clear to all of you? Yeah, sorry, my bad. It's 46. So still, it's my MR is greater, right? Okay. Now, the rate of diffusion of nitrogen monoxide decreases as the temperature decreases. Suggest why using the idea about kinetic particle energy. So what happens at to the lower temperature? Yeah, the molecules move slowly because the kinetic energy of the particles decreases, right? So the NO molecules move slowly as the kinetic energy decreases. Is this understandable to all of you? No, how they do vibrate? It's a gas, Khatija. It's not a solid. In solid, particles vibrate. In gases, they move. Why the particles would less? The particles are same. Only the kinetic energy would decrease, which makes the molecules to move slowly. Now, question number 10. PVC, polypropene, and polypropene are polymers made by the reaction called addition polymerization. The diagram figured in figure 10.1 shows the structure of PVC. Draw the structure of the monomer used to make PVC. So see, identify the repeat unit. See, these all are repeat units. So when you identified the repeat unit, draw it again, but don't make the bonds on which are on the left and right. Instead, put a double bond over here so you get the monomer. No, they don't ask you to draw the one unit. If you have to draw the one repeat unit, you have to draw this thing only with the bonds, empty bonds on both the sides. But they ask you to draw the monomer, so you have to show the double bond in it. Okay. Now, B part. Polypropene is a polymer used to make plastic food containers. In the diagram in figure 10.1 shows the structure of the polypropene. Some waste polypropene plastics is disposed by burning. This makes a toxic gas because of incomplete combustion. Name this toxic gas. Yes, when there is an incomplete combustion. Yusuf, when did you study car CFCs? Whenever there is an incomplete combustion, yes, Khatija, yes, Zaid, yes, Hania, yes, Kamar, yes, Zaid, Ahmed, Rahim, Shayan. Who else? Umar, Abdul Hadi, very good. So what we get? We get a carbon monoxide. There is a no fluorine and chlorine and you are saying CFCs. Yes, very good, Harun. State one other chemical environmental change caused by the disposal of waste polypropylene plastic. Explain how this challenge is related to the properties of polypropylene. Yes. Yeah, so if you do this, if instead you write the formula and no, it doesn't cause acid rain. That is not the part of the syllabus now, so you don't have to talk about CFCs. Yes, very good, Harun. They does not react, they does not, and the one environmental challenge is that if we are not burning, because they have discussed the burning, we have to discuss any other side. Yes, the landfilling problems. So the landfills get filled if you dispose of by putting them in landfills. So what happens to that? That landfills get filled, and if the landfill gets filled, so we have no other place. So how can we explain it? Because these are non-biodegradable, and do not react. That's why they stay as they are. They cannot be decomposed. Yes, that can be also considered correct, Hania. Okay. Name one condensation polymer. Draw the displayed formula of the linkage between the repeat unit in this polymer. Okay. So the most common one is a nylon, right? And you have to show the displayed formula of the linkage. So in the ethyl ethanoate is Harun, it's an ester. No, they do not decompose for the previous one. So a nitrogen is bonded to a carbon, and that nitrogen and has one hydrogen, and that carbon has a double bond. So this is the linkage which is between. No, it's not nylon only. For example, we studied nylon, we studied polyester, PET, and we studied protein as a condensation polymer, right? Okay, let me show you guys. If you guys go through the note, you can understand. I've shared it in the past paper WhatsApp group. See, condensation polymer. There are two types, polyamide and polyester. If it's a polyamide, then it has a amide link. And if it's a polyester, then it has a this link. Is this understandable? And the example of polyamide is a nylon. So I have mentioned nylon. So that's why I show this linkage. If instead, if I show a PET, if I show P, if I have written PET, then I'm going to show this link. Is this clear? Or for example, there is another polymer that is a condensation, it's a protein. So if I mention protein, then I'm going to show this link. Yes, is this clear to all of you? So see, if I mention nylon, I use this. Instead, for example, if I write protein, so I'm going to use this link only. But if instead of these two, if I'm going to write PET, then I'm going to show this link. No, pteryline is previously in the syllabus. Now it's not pteryline. So if you look at the notes, I have mentioned PET, not pteryline. So you have to write PET, not pteryline, okay? So here we have ended the paper. Now, I think tomorrow we are going to do another May, June 2023. We are done with the 2-1, so we are going to do 2-2. Okay. So see you everyone in the next class. Take care. Goodbye. Allah Hafiz. Yes, I'll confirm.